In this video, I will show you how to create a paper folding animation in Blender. This is a beginner-friendly tutorial, so you can follow along easily. We start with a flat sheet of paper. Then, step by step, we fold it into a new shape. Open Blender. Press A to select everything, then press Delete. I have enabled screen keys, so you will be able to see every key I press on the screen. Now go to the Geometry Nodes workspace. You will see 3 panels. Adjust each panel by dragging the edge of the panel to change its size. If you want to combine 2 panels, go to the top corner of one panel and drag it into the other panel. Then, change the editor type and select the 3D viewport. Move your mouse to the 3D viewport, then press Shift plus A and add a plane. In this panel, you can see the 4 vertices of the plane and their position values. Next, go to the Geometry Nodes tab and create a new Geometry Nodes setup. For the first step, we want to rotate the plane on the y-axis. But only on one side. We only want to rotate the area where the x value is greater than 0. Add a set position node. This node lets us control the position of each vertex. For this step, we only want to control the x value. So add a separate x, y, z node and use it to isolate the x component. Next, add a position node because we need the position of each vertex. The separate x, y, z node will take that position and give us only the x values. Now we need to choose which vertices should be affected. For that, add a compare node and set it to greater than 0. Now you can change the offset values, and it will only affect the vertices with positive x values. Now we want to rotate the plane. For that, connect the set position node to a vector rotate node. Set the axis to the y-axis, so use values 0, 1 and 0. The center is the pivot point, and since the origin point is already in the center, that is fine. Next, add a position node and connect it to the vector input. Now select the plane and go to edit mode. Right-click and choose subdivide. Then open the small panel in the lower corner and set the number of cuts to 100. Now when you change the angle value, you will see the plane rotate around the y-axis. For this next part, we need to rotate a triangular section along a diagonal axis. Go back to the Geometry Nodes editor, Select the previous node setup, then press Shift plus D to duplicate it. Next, we need to select the triangular area first. For that, I already prepared a script for triangular selection. Go to the scripting panel and add the script there. I will leave the script link in the description. After you paste the script, click Run Script. Then select these three vertices first. Press N to open the side panel. Go to the Triangle tab and click Select Inside Triangle. Now you will see the triangle area selected automatically. Now go to Object Data Properties and open the Vertex Group section. Click the plus icon to add a new group, then rename it as 1. After that, click Assign. Now you can see that a new column has been added to the data. Some vertices have a value of 1 and the others have 0. That is because the selected vertices were assigned with a value of 1. Now go back to the Geometry Nodes tab, add a named attribute node and connect it to the selection input. Change the type to float, then enter the attribute name. Next, we need to isolate only the selected vertices. For that, add a compare node and set it to greater than 0. Now add a vector rotate node and connect it to the position flow. This time the axis will be a diagonal one. So first press Shift plus A and add an empty. Place the first empty at one corner of the diagonal. Then press Shift plus D to duplicate it and move the second one to the other corner of the diagonal. Rename them as A and B. Now drag both empties into the Geometry Nodes editor. Add a vector math node and set it to subtract. Connect the location of both empties to this node. This gives us the rotation axis. For the center input, you can connect the location of either empty. Then add a position node and connect it to the vector input. Now, if you change the angle, you will see the selected part rotate. After that, select this whole node setup and press Ctrl plus G to group it. Inside this group, create inputs for the vertex group, the angle, and both empties. Now this becomes our main group node setup. Now for the third step, select the group we made earlier and duplicate it. This time we need to define another vertex group. In this case, we need to select a triangle like this. Also, the distance on both sides should be equal. We already know two vertex points. Now we need to find the third vertex so the distances stay balanced. First, select one vertex and use the triangle selection method. Then create a new vertex group and rename it as 2. Next, press Shift plus S and move the cursor to the active vertex. Now the 3D cursor will snap to that active point. To measure the balance, we need to check the vertex count. For that, enable statistics in the viewport. Now you can see the number of selected vertices. In my first selection, one side had 25 vertices. The other side had 34. So that means the triangle is not balanced yet. Now I move the point and try another position. Again, I select the three vertices and run the triangle selection. Then I check the vertex counts on both sides. If the counts are still not balanced, repeat the same process. Move the point, test again, and compare the counts. In my case, I had to adjust it one more time. Now the selection looks correct. And create a new vertex group. I delete the previous group, create it again, rename it as 2, and assign it. Next, select the empty and duplicate it, move it to the lower corner. Then go back to geometry nodes, change the vertex group input, and also update the empty. Now if you change the angle value, you can clearly see what is happening. At this point, step 3 is complete. Now let's move on to step 4. Duplicate the node group one more time. Next, we need to select half of the plane. This part is simple, so you can define that selection by yourself. Then select the empty, duplicate it, and move it to the new rotation axis on the Y direction. And then select the correct vertex group and the empty for that step. For the fifth step, this area also needs to follow this shape. And these two distances should be equal. First, select 3 suitable vertices and create the area selection. Then go to the toolbar and choose Circle Select. Use it to select the remaining vertices. Make sure X-ray is enabled and hold Shift while selecting. Now create a new vertex group and assign it. Next, press Shift plus S and choose Cursor to active. Then check the vertex count and see if both sides are approximately balanced. In my case, it was already close enough. If your result is not balanced, you will need to adjust it. After that, select the vertex at the end of the rotation axis. Press Shift plus S again and move the cursor to the active vertex. Then select the empty, duplicate it, and press Shift plus S. Choose Selection to Cursor. Now select the correct vertex group and the empty. At this point, the step is almost complete. Now we need to place the last empty in the best position. For that, go to Object Data Properties and adjust the values. Set X to 0 and then change the Z value depending on the shape you need. Now go to Edit mode and delete half of the mesh. Then go to the Modifier tab, search for mirror and add it. Now you can see the final clean paper jet shape. Go to Edit mode and select All. Bring the open edges close together using the Move tool. Now you can animate the folds using your own angle values. You can adjust the timing and movement however you like. To make the paper jet look smoother, you can also add a subdivision surface modifier and a solidify modifier. That will give the model a cleaner and more polished paper look. Now you can use the same method to create your own paper folding animations and even experiment with different origami style forms. I hope this tutorial was helpful. Thank you for watching, and I will see you in the next video.